Have you ever thought, what have the ancient Greeks ever done for us? Well, they gave us democracy. Enough of that then. Some incredible architecture, the Olympic Games, trial by jury, the theatre, and a whole bunch of great philosophy. And one in particular, a philosopher called Pythagoras. He was the first to prove mathematically the relationship of the elements of a 90-degree triangle. As carpenters and builders, we use this relationship, now known as Pythagoras' theorem, to enable us to set out buildings, make staircases, and build roofs. And that's just but to name a few things. So, let's take a closer look at Pythagoras' theorem in a lot more detail. Before we can get started using Pythagoras' theorem, we need to know the names of the sides of a triangle. So let's start with the longest side, that one there, and it's called the hypotenuse. So Hypotenuse, hypotenuse. The next longest side, down at the bottom here, is known as the adjacent. So we'll type that in. Adjacent. Done. Move that along a little bit. And the one at the far end, the shorter one of all the sides, this one on the far corner, is known as the opposite. So how can this help us with our work? Well, let's take a look at the staircase. A staircase is in fact a triangle, but it has different names. So let's put the names of the triangle on first. Okay, so we'll start with a long one. And on the triangle, the original triangle, this was called a hypotenuse. On here, this is called a string. Okay, so that's called a string. Along the bottom, we run along there, just from that point to that point, that was called the adjacent, and on here it's called the going. Okay, like so. We'll just put that up to there. And finally, what was the short side, we're going to put it in there, from finished floor level to finished floor level. That was called the opposite, and on here, this is going to be called, or this is called, the rise. Put that over there. So, what we'd like to do now is see how that fits in with our triangle. So hopefully, if we bring our triangle in like this, and we select it, bring to front, like so, okay. We can now move into place so we can see how our triangle fits in. The long side, which was the hypotenuse, is now the string, or the length of the string. The shorter side, end here, that was the opposite, is now the rise, and along the bottom we have the going, which was the adjacent. Let's now consider our triangle in relationship to a roof. A roof is a very similar shape. It is in fact a triangle, but it again has different names. So let's start with the long side again, and this time it's going to be called a rafter. Put that in there. That's the rafter. The distance from the top to the bottom down here, that is in fact called, same as before, that's called the rise.
that in there. The distance all the way across the bottom, all the way across there, from there to there, that's called the span. Pop that in there. And the distance halfway across the bottom, so just from there to there, that distance is called the run of the rafter, or simply the run. Okay, if we take our rafter again, I'll just put that back because I picked the wrong thing. Bring our rafter in, sorry, if we bring our triangle in, and again we move it to the front. Will in a minute. So there's our triangle. If we move it up, it doesn't fit perfectly, but there's our triangle. And so what was the hypotenuse is now the rafter, what was the opposite is now the rise, and what was the adjacent is now the run of the rafter. Pythagoras tells us that the hypotenuse is equal to the sum of the square of the other two sides. So that's the calculation, or the formula, that we'll be using to calculate it later on. Pythagoras also tells us that if we know two of the values of a right angled triangle, we can calculate the other. Let's calculate the length of the hypotenuse, string or rafter. The first thing we need to do is square 50. So we'll start out by taking 50 and multiplying it by 50, which will give us 2500. Then we need to multiply 25 by 25, which will give us 625. We need to add them together. So if we add them together, we're going to get a total of 3125. And to actually find the exact length of the hypotenuse, what we need to do is we need to find the square root of that, which is 55.90, which will be the length of the hypotenuse, string or rafter. To find the angle at A, all we need to do is divide 25 by 50, so we'll start by 25 divided by 50, which will equal 0.5. And then on our calculators we need to press sine minus 1, which will equal, in this case, 30 degrees. We can also invert tangent on some calculators, but on most, sine minus 1 will give us the answer that we need. And so down here, the angle of that is 30 degrees. Okay. To find the value of the opposite from the adjacent and the angle, first we enter 30 into our calculators, and then we need to press sine, which in this case will give us a value of 0.5. We then need to multiply that by the adjacent, which in this case is 50, and that will give us a value in this particular instance of 25, which is the value now of, just cross that out, 25 millimeters. A very useful fact about a right-angled triangle is that it will always contain 180 degrees. Therefore, it's very easy for us to find the angle of, for instance, a plumb cut on a rafter. All we need to do is add up the existing degrees that we know, in this case is 90 and 30, and add in the extra to make it up to 180 degrees. Therefore, we know at the top here, for instance, in this particular triangle, it will be 60 degrees. So our plumb cut for our rafter, that is the cut right at the very top, plumb cut, will be 60 degrees. And we can set our sliding bevel to that to make life very easy.